Alrighty, Math 20-1, we are on to Quadratic Functions Equations Lesson 9. Wrapping up this section of the book, we're on to the next section starting next week. Alright, we are on to basically applying these quadratic functions but using an algebraic approach. So last lesson was a graphical approach, now we're going to approach these algebraically. There will be questions on quizzes or tests or assignments in the future that say algebraic. And what that means is that you have to show me all the math involved in solving this, right? You can use your calculator to find the solution, but you definitely need to make sure that you have all of the math shown, right? So some review, we're going to be basing a lot of this off of our vertex, okay? And our vertex is in standard form. All right, so we have to go from general to standard form. Remember, if we're going from general form to standard form, we're going to have to complete the square. Remember, we're doing this algebraically. We can't just throw in our calculator and just go from there. We have to complete the square, right? So what we've done here for algebraic is basically, remember the coordinate vertex. This is standard form here with the P and the Q in it. Okay, that's standard form. All right, and our vertex here is PQ. Okay, P is the X value, right? If A is less than 0, it has a maximum of Q, and if A is greater than 0, it has a minimum of Q. All right, so the equation of the axis of symmetry is X equals P. Okay, so there's just reviews as to basically how to do this. All right, the nice thing about standard form is it tells us our max and min, right? And so what we're going to do is we're going to basically redo question class example number 1 from lesson 8, but we're going to do it algebraically now, right? So the height h in meters above the ground of a projectile at any time t in seconds after the launch is defined by the function h of t negative 4t squared plus 48t plus 3, right? And so if I look at that, what I did here is I need to write it in standard form. Okay, we're writing standard form. So the first thing I did, right, was I factored that negative 4 out and left myself a gap, all right? Then what I'm doing is I'm completing the square. Completing the square means that I am going to add and subtract 36. Remember, we're going to add 0, right? I'm going to add and subtract 36. So I added 36 and subtracted it. Where to get 36 from? Well, that's 12 divided by 2 squared, right? You're going to take the 12, the middle number, divided by 2 and squared. That's how you complete the square. All right. Then I took the 36 out, and it became positive 144. Why? Well, I had to take the negative 36, and on its way out, it has to be multiplied to the negative 4. All right, it has to be multiplied to the negative 4. Okay, so it becomes positive 144. I then simplified by reducing this to a perfect square trinomial and 147. That tells me that my vertex is at 147. That's good. Okay, now we're going to basically answer the rest of the questions. Okay. So find the height of the projectile after 3 seconds. So if it's after 3 seconds, we just put in 3 for the seconds. And we'll just use the equation we just made, right? So we say h have 3, so we say it's negative 4, 3 minus 6 squared plus 147, which we can, of course, just punch into our calculator. Gives us 111 meters. Okay, 111 meters. All right, so and then we check it. Okay, so what is the maximum height reached by a projectile? Well, we don't have a calculator to tell us, but we already know that. It's based on our vertex, right? Okay, our vertex, the maximum height is going to be our Q value. Well, Q in this case equals 147. So the maximum height is 147 meters. How many seconds after launch did it reach the maximum height? Well, that's going to be our P value because X is representing seconds. So this is going to be 6 seconds, right? And what was the height of projectile at launch? Well, that would be when our t equals 0, which is going to be that our height equals 3. All right, that's just the number at the end there, okay, right, of our general form, right? That's our c value, which is going to give us this. All right, so determine when the projectile hits the ground to the nearest tenth of a second. So what we did in the previous lesson, right, is we basically just put in our calculator and found where the x-intercept was using the 0 function. Well, now we can't do that. What we have to do, though, is we just solve where does this equal 0, right? Where does this equal 0, right? And so this is where we're kind of bringing everything together. We could factor it, right? But there's not really that factorable. We could try to do different squares, but we don't really want to do that anymore, right? So what we're going to do is we're just going to go ahead and put it into the quadratic equation. Okay, so you could solve when this equals 0. They're both the same equation. So you could take that and say it equals 0. Sorry, not that one. Yeah, this one. When it equals 0, but it's just going to be a little bit easier to do it this way because you're going to get a little more, a little bit quicker. All right, so I listed my A, B, and C values. I did my quadratic function. I put it together. I simplified it to this, right? And then I put in my calculator. So right here is when I put in my calculator. Okay, and it gave me these two answers. Now I put approximate. Why did I put approximate there? Well, the reason I put approximate there is because we have rounded these numbers, right? It's not exact. All right, and we're going to get two answers. We get negative 0.1 and 12.1 seconds. Well, sorry, I'm going to sneeze. Oh, excuse me. So we got 12.1 seconds. So the reason we reject the negative 0.1 is because it doesn't make sense to have negative time in this case, whereas we were going to want basically to have the positive one, so it gives us 12.1 seconds. And what do we notice is that if we compare them with our answers on page 347, we got the exact same. So we can do it algebraically or their calculator, but lots of questions are going to ask us to do it one way or another. Okay, so you can assume, not assume, but basically if it wants to be done algebraically, the question will say be done algebraically. All right, so I'll zoom out here, give you guys a second to copy that down. Alrighty. Okay, so now we're on to page 2, okay? So a rancher has 300 meters of fencing with which to form a rectangular corral, an enclosure for confining livestock. They have to tell you that because when they have, someone from Calgary who's never seen a cow before, he has to understand what the word corral means. They do this in diplomas too. If there's ever a word that is not universal, they usually try to explain what that word means, but sometimes it's kind of funny. So one of those, which side's an existing wall. So I drew the existing wall in black here, okay. And so basically, two sides of the rectangle are each measured in x meters. Show that the area of the corral can be expressed in the form ax equals 300x squared. So this is one of those questions where they gave us the answer, right? They gave us the answer, but we have to get to that answer algebraically. And so I drew this out. Right, and here's my corral. The red is the fence, the black is the wall we've already made, and I want you to take note that the width of this is x, right, is x. So if this side's x, and this side's x, and this side has to be what? Well, it's the total minus 2x, right? It's 300 minus 2x, because there's 300 in total, and I've already used a sum up for x and x, right? And so now we got to say the area. Okay, well, we know that area is length times width, obviously, right? So the area should be length times width. So the length is 300 minus 2x times width, which is x. So then my area is going to be 300x minus 2x squared. All right, so see how if it tells me to show, okay, I've basically shown the math, shown all the thought process, and I've given them back the answer that was offered to me, right? Okay, so now we are going to use the method of completing the square to determine the maximum area possible. Okay, so we want to find the maximum area. So we take this equation, we're going to rearrange it a little bit just so it's in the correct order. So A equals negative 2 x squared plus 300x. All right, and what we're going to do is we are going to now factor and complete the square so that it gives us the vertex, right? Remember, whenever it asks for the maximum or the minimum, we have to find the vertex. And the best way to do that is by completing the square. Okay, so this is now going to equal, factor out the negative 2, excuse me, with x squared plus, oh, not plus, sorry, minus 150x. All right, now we're going to take 150, we're going to divide it by 2 and square it. Then we're going to add and subtract that, okay? So 150 divided by 2 is 75. And squared is going to be 5625. Okay, and remember we're adding and subtracting 0. Right? Okay, this adds together. We're not really changing the equation. We're just changing the way it looks. Now we got to take that negative out. Okay, so we're going to take this negative out. This negative 5,625, and we're going to multiply it to this negative 2. And then once we do that, we're going to bring it back around to the end, but outside the bracket, right? It's going to go outside the bracket, okay? So just a review on how to or how to complete the square. So this gives me negative 2 x squared minus 150x plus 5,625 plus, right, it's negative 5,000 times negative 2 plus 11250. Okay, so that's that. Now we have a perfect square here, which we can reduce to a binomial. All right, so we'll bring this up here, and we can say that the area equals negative 2x minus 75 squared plus 11,250, right? So now we're in vertex form. So now I need to find the maximum, right? Which tells me that the max area, right, is our vertex, right? Our vertex is at 75, 11, 250. That's our vertex is. So it tells us that x should be 75 at the max, and our area should be 11,250. So the max area is going to be 11,250 meters squared. So that's the maximum area we can get. All right. Okay. A good habit to get into when you're doing algebraic questions is to always express your answer at the end in very clear form. If you want to circle it or square it or whatever. Because if you go through algebra, the deeper you get into math, the longer and harder the algebra gets. You really want to make sure that it's very clear what your answer is and what your answer is exactly. Okay. So the most stated dimensions of the rectangle, which gives the maximum area. So we're told that x equals 75, so that's the width. Right, that's the width, and then the length, right, would be 300 minus 2 times 75, which would be 150, which is our length. So our dimensions, it is a 150 meter by 75 meter rectangle. Okay, so there's the math for that whole question. Again, feel free to pause the video. All right, this should be making sense, you guys. I hope we're getting there. Okay. So, Ashley was asked by her math teacher to find two numbers which differ by 8, whose product is a minimum. All right. So if x represents a smaller number, write a quadratic equation in x for the product. Okay. Remember the word product means multiply. Okay, so keep that in mind. So I have the small number, which is x, that's my first number, and my second number, the larger number, right, is x plus 8. Those are my two numbers, right? So then the product, which in this case we'll just call P, is equal to x times x plus 8, which is going to be x squared plus 8x. All right. So we're going to write the product in completed square form, right? Why are we doing that? Well, because it's asking for the minimum, right? It's asking for the minimum, so we can determine the numbers in the minimum product, right? So we're going to take that and we're going to say, okay, well, P equals x squared plus 8x, okay? All right, so we don't have to factor anything out, so now we can just go ahead and complete the square. So I'm going to complete the square by adding and subtracting what? Well, we're going to take 8 divided by 2 is 4 and square it. So we're going to add 16 and subtract 16, right? Then I'm going to basically take a look at just this part, right? And I can arbitrarily add brackets. You can always just add brackets to stuff. Not arbitrarily, but as long as it's in a great place. Okay, we're going to break that down, and we're going to be left with P equals x plus 4 squared minus 16. So that tells me my minimum, right? That tells me my minimum. My minimum is at the point -4, comma, -16. That's my vertex. That's my minimum, right? So therefore, my min product is right there. My minimum product is -16. That's the lowest we can have, right? I also know that my x should equal -4. If x equals -4, then what is my other number? My other number is going to be -4 plus 8, right? Which tells me that, so I have +4. So the two numbers are -4 and 4, right? So again, we gotta double check that, right? Ashley was asked by her math teacher to find two numbers which differ by 8 and whose product is a minimum. Okay, so -4 and 4, do they differ by 8? And the answer is yes. Do they have a product that's a minimum? All right, and so there is this concept that you could have you could have 0 in there, right? And I don't know why it comes up with this. You could have 0 in there, but 0 is not less than -16. We're trying to get the most negative number we can get, right? And so -16 is far lower than 0, right? 0 and 8 would give you a product of 0, right? And so this is the lowest we can go without the lowest possible product, right? So keep in mind, there's sometimes that you hear the word minimum, you're going to think, well, I'm going to try to get to 0. But it's actually, in this case, minimum is the most negative, alrighty? So that is the end of this lesson. We are not doing, we are not doing the vertex formula. It's you can do it, you can look through it and stuff. It's not the best way. It's easier just to complete the square and get it over with. All right, so you don't have to worry about completing assignment. Don't complete question 10. You can complete the rest 1 to 9. All right, and that is the end of quadratic functions.